bonds. Whenever an atom forms a compound, it is attempting to get a full, stable outer shell of electrons, which, as we know, makes it follow the pattern 2-8-8. If it has one shell, it wants to have 2 electrons in that outer shell. If it has 2 shells, it wants to have 8 electrons in the outer shell. If it has 3 shells, it wants to have 8 electrons in the outer shell. The easiest way for them to do this, to fill up their shell, is to either lose the electrons in their outer shell, making the next one down the full outer shell, or gain enough electrons to fill up that outer shell and make it full. Which one they do, lose or gain, depends on their position in the periodic table. Metals on the left, they are going to lose electrons to form positive ions. Remember that electrons have a negative charge, so if you lose an electron, you end up with a positively charged ion. You're minusing a minus. Non-metals, except for hydrogen, which is a special case, gain electrons because they're trying to fill up their shell, because it's easier to do so. If you gain electrons, you end up with a negative ion because electrons have a negative charge. Eventually, when they form these ions, they will get the same electron configuration as one of the noble gases, which have full outer shells. 2 for helium, 2-8 for neon, 2-8-8 for argon. That means that when you've got a full outer shell, they will now be stable, very unreactive. If you react a positive ion and a negative ion, so a metal with a non-metal, you will end up with various combinations of positive and negative ions. And opposites attract. Kind of like a magnet with their north and south, but it's positive and negative. Opposites are going to attract. If you've got positively charged ions and negatively charged ions, they're going to stick together. We call this attraction an electrostatic attraction. So it's an electrostatic attraction. It's the attraction between oppositely charged ions or particles. A classic example of a compound that's held together by electrostatic attraction or ionic bonds is common table salt. The formula for common table salt is sodium chloride. A sodium atom is going to lose one electron to form a positively charged ion. The chlorine is going to gain that electron to form a negatively charged ion. We can represent with these dot and cross diagrams. Notice that we've used a dot and a cross to show different electrons from different atoms. So we can see that the chlorine's extra electron has come from the sodium originally. So the sodium has a positive charge, the chlorine has a negative charge. The electrostatic attraction sticks them together, at the end forming giant ionic crystals, which we'll cover in a later lesson, the properties of those. Opposites attract and stick together, and that helps us to build the formula of ionic compounds, even ones that we may not have seen before. The overall charge on a compound has to be 0. So in sodium and chlorine, we've got sodium forming a charge of +1 and chlorine forming a charge of +1, -1, because it gains an electron. So if you've got +1 and -1, that's neutral. They cancel each other out. So every time you have one sodium, you have to have one chlorine. So the formula for sodium chloride is NaCl, one of each ion. However, ions sometimes form that have more than one charge. So here's an example. Magnesium is a metal in group 2 of the periodic table. It forms a 2+ ion. That's an ion with a 2+ charge. Chlorine, we saw that before, it's got a -1, it's got a -1 charge. So if we want an overall balanced molecule, ionic compound, then every time we have 2 positives, we have to have 2 negatives. So I get 2 positives from one magnesium atom or ion, but I only get 1 negative from 1 chlorine ion. So the ratio has to be 2 chlorines for every 1 magnesium. That gives us a formula for magnesium chloride of MgCl2. 2 chlorines for every 1 magnesium, 2 negatives for every 2 positives. So overall, remember, metals lose electrons to form positive ions. Non-metals, except hydrogen, gain electrons to form negative ions. The molecules are stuck together with an electrostatic attraction, and the molecular formula for an ionic substance has to balance the positive and negative charges. All right, thanks for watching.